This is a talk by Professor Simon DeDeo, hosted by me and recorded at the Iliad Conference in Berkeley, California. I've done some light editing, mostly to make audience questions concise and relevant, a power I am now deeply sad I don't have in real life. Hi, everybody. Thank you for coming. I'm Elizabeth Van Nostrand. I'm a science writer who's currently doing an investigation on how do new paradigms form and how can we speed them up. This is Simon DeDeo, who has done a lot of things that maybe you can describe. I will forget some.
Interesting being here at this meeting because there's a theory that people are doing, where people are doing learning, theory of learning, how machines learn, decision theory for optimal agents. So there's a lot of theoretical work that people are talking about, a lot of a priori reasoning about how we increase our knowledge, how we flourish in our society. So that's great. And I do empirical work, do a lot of empirical. And so my question for you is, are you winning? And, do you want to win more? And what I mean by that is that we have a lot of theories, and you guys are building theories about how we can learn or how machines can learn. You're building theories about how we can increase our knowledge. What I became increasingly interested in was this idea that we could figure out how to increase our knowledge by looking at how historically people increase it. So to a certain extent, I do psychological experiments. So I put people in laboratory scenarios, some undergrads, and I get them to have conversations and see, do they, improve their explanations for puzzling phenomena? But a lot of what I do is look at things in the historical record where people have been extraordinarily, stunningly successful. And I think this is, Elizabeth, what you're interested in, people who have been involved in paradigm shifts, our knowledge. So I think of myself as looking at how people have actually succeeded. That should probably trump our theoretical beliefs about how we succeed. And so part of my role here, I think, is to be a bit provocative. Because a lot of what we find, and this was frustrating early on when I first started looking at how people did science, for example, truly successful science, it was very frustrating because all of the things that we were discovering were very counterintuitive and violated all of our accounts of how. I think that's one of the things, and I've already had some good arguments with people here about, yes, it makes complete sense that doing X would get better science, but actually, if you look in the record, you do not X, it works. So a lot of what we're doing is, and I didn't intend this to be the case, but we ended up finding a lot of empirical counterexamples to things that seem really, really sensible. Elizabeth was really interested in Darwin. Charles Darwin, you may be familiar with Charles Darwin from everything. So, Darwin, I think, has claimed to be the Newton of biology. The shocks of his paradigm shift are still shaking us, right? If you read how people were responding to Newton in the 1800s, it was, that was shocking. People were still Newton is blowing my mind. I can't handle this. He's destroyed everything I thought was real. We're actually over that now. As a civilization, Newton has now become normal. Darwin still is really not normal. And it's not normal for social scientists, for example, to think in Darwinian fashion. It's not normal for political scientists to think Darwinian fashion. It's still extraordinarily controversial. And it's controversial not necessarily politically, but just controversial because that's not how we ought to reason, and yet reason, or at least things that work really well. So Darwin is somebody who created these kind of shocking paradigm shifts for us. And the question we had is why, or how is he able to do this? Yes. So there's things like evolutionary psychology, right? Evo-psych is somewhat controversial, but it's controversial largely there because of the relationship between biology and culture, right? And that's going to be endlessly debated. A lot of accounts we had of evolutionary psychology early on were facile, and so I think Sorry, psychology is a big field. I call myself a cognitive scientist, and there's a lot of really good stuff there. Early evolutionary psychology, what we call the California school, and I take these phrases from a colleague of mine, Helena Mitton, at Stanford now. Um, the California school really had a very strong account where there are these modules in the brain, and the modules emerged, there's the cheater detection module. There's not a lot of evidence for the existence of a cheater detection module. So we have better pictures of how this works. Of course, a lot of us do make evolutionary arguments. But in the mainstream, it's still controversial to talk about why something might have emerged through a process selection. We often like rational accounts or accounts of social behavior that you might think of as a rational reconstruction of why we do, which is almost like a teleological account, or the way they. But yeah, it's still controversial. And again, not necessarily politically. It's just like people aren't used to thinking that way, and for some people, it really bothers. But yeah, so there's this question, like, how did Darwin do this? How did Darwin come up with the theory of evolution? There's a standard story of how we do this, the standard story of how we discover things, and it goes by the name explore, exploit. So the standard story is you want to discover something, you're in some landscape. Some of this we draw from animal behavior, like you're foraging in a landscape. And, step one is you explore, like you kind of go around and sample, and you look over here and sample a little bit, right? You go over here, you sample a little bit. And at some point you shift from an exploration mode into an exploit mode. You're like, wow, this bush has really good berries. This field has really good stuff going on. And I'm just going to sort of dig down and exploit that resource for a while. Right. So the metaphor is a metaphor of mining, the metaphor of foraging for fruit in bushes. Some of them have more fruit than others. So that's the standard story. And the standard story makes this very standard prediction, which is first you explore, right? And then you exploit. And my sense is that if I look at the standard theoretical accounts for how you should play the multi-armed bandit, right? Presumably there's an explore phase. And you pull a few, and depending upon your risk tolerance and your fear of regret, you'll pull for a while, and then you'll just start pulling one, right? So that's classic explore, exploit. So is it true? And you might say, well, how could it not be true? Like, that's got to be what it is. So what you're exploring here is, in the Darwinian case, so when we examined this, we looked at which books he read, right? Where you go in the library, like, physically, right? People have looked at explore, exploit in web surfing. Yes.
My understanding from the paper where you analyzed what Darwin read is you're analyzing when he was exploring and exploiting relative to his own baseline, not relative to the landscape of books as a whole.
Right. So instead of a multi-armed bandit where you're pulling levers, imagine you have a library of all the scientific knowledge we have so far. So like Darwin had a library. He had a library. And so he's walking around pulling books off the shelf. So let's imagine this library is organized so that books that are more similar are closer to each other. And so the question is, does he explore first and then exploit, which would be the standard prediction from like a lot of things that theorists would say, theorists in machine learning.
Where explore would be going around to different shelves.
Exactly. Going more
like
distant,
random
right?
pulls would be fully explored.
That would be a great example. Yeah. Does that make sense? Exactly. And that's a pretty compelling story. To a certain extent, it's hard to see how it could not be, right? So for example, I mean, I know you could see it coming, right? But think about how, for example, we set up education, at least in the United States, right? 4 years of college in the United States. First 2 years, take some general electives, take a class in Russian, take a class in linguistics, take a class in math, right? Kind of explore around. And then when you find something that's really vibing with your special abilities and your interests that you could really dive into, junior and senior year, we're going to do your capstone thesis. You're going to really dig in. That seems so intuitively true. It's hard to understand how it could not be true, right? When somebody comes, I don't know, somebody joins Lighthaven, right? And they don't know what to do next. You're like, you know what? Just talk to everybody. Just walk around, see what's interesting, poke around, right? And then when something hits you, dive in. That's explore. That seems like really good advice to give to. The only problem is Darwin does exactly the opposite. So that intuitive story that's backed up by how we do things culturally, how we set up education, right? We don't, you do your A levels after you've had a general education in the UK at least, right? In the US, you do your liberal, you kind of spread around a little bit. You have your survey course at Columbia. What we do intuitively, what we do culturally, if I go to talks here, people are going to play the multi-arm bandit this way. And this is a good analogy for really hard problems, right? It's just empirically true, right? At least that's not what Darwin. That's one case study of somebody who really did. So don't do that. Do not explore, exploit. That to me is really tremendous. Yes, I know, right? Right. So Darwin is just one case, right? And this is one paper. It takes a while to dig into this. We're lucky with Darwin because Darwin was an early, he's like an early Gwern, right? Like an early life hacker. And he kept really detailed records of all the books he read. We know which book he read and we know when he read, from when he gets on the Beagle to when he comes back and right through until the end of his life. So this was work Jamie Murdoch, who's now doing top secret classified work at Sandia, worked on this, and Colin Allen, who's a philosopher. He's now off California somewhere. But we were working together in Indiana on this. You asked okay, how much data we have? This is a case study, right? You can say, I do not recommend I do recommend we tear apart our educational system, but not on the basis of this one paper. But one of the reasons I think it's useful for us to be here at this conversation is this is pretty striking evidence in the other direction. Now you might say, actually, Simon, if you did it right, you would find what we always find in our theories and in our intuitions and our culture, which is first explore, then exploit. Can't be right. Okay, fine, right? We can neglect the evidence, or we can sort of say it must be mistaken. But it's something that I think is really worth putting out on the table. Wow, what if we're really wrong about all of this?
And right.
Empirical evidence is great. So what we find is we have two measures of this exploration behavior. You can think about local exploration. So how big are your jumps from moment to moment? And you can think about a more global notion of exploration, which is how big is your jump compared to everything you've seen so far. So local and global can vary independently of each other. So an example of local exploration and global exploitation is right? I'm going to read applied math. Tomorrow I'm going to read Cog Sci. Next day, right? I can flip back and forth. That's locally explorative, right? From one book to the next, it's a big jump, but I'm basically staying confined in a space. And then you can see the opposite case as well, which is where you have you have local small jump locally, but you're kind of random walking or even beyond random walking, self-avoiding random walk away from where you be. What we find in Darwin is that he starts in an exploit mode. He's just as early back as we have his data, he's obsessively reading in a narrow place.
Where did he start?
So he starts it's usually in biology. There's a small number of books he reads early that we might think of them as kind of demography history book. So he reads Malthus quite early, for example. Malthus being the guy who says, we're going to reproduce right up to the limit of misery. He shifts into he starts becoming locally explored. But globally, he's pretty stable. That's a good question. Early 20s, but Jamie will correct me on this because Jamie did a lot of the. So he's moving locally, but he's kind of jumping. He's staying confined. So one example is early on, he's obsessed by barnacles. He's just reading about barnacles all day, and there's a lot of barnacle books, right? It's literally only at the end of his career and life does he actually switch to the standard thing we tell students to start by doing, which is exploration, right? Which is pure exploratory mode. And when you do this model, we have these tracks. It's these, track. You do a very simple Bayesian model to look for epochs in his life when he switches away from local exploit to local explore, and then when he switches from global exploit to global explore. The first switch happens. It's a really interesting moment in his career. He's about to write Origin of Species, The Origin of Species, and this like top sci writer in Scotland comes up with a book called Vestiges of Creation, and he's like, "Fuck, excuse me, this was the book I was going to write. I've been scooped, right?" And he reads this book, and cartoonishly, he says essentially, "God, I didn't write my because I've seen the book I would have written, and it's so full of holes. This is not, thank God, right? I'm glad somebody else made the mistake that I didn't make." And then he really gets going. The day, it's quite spooky. I mean, science is real. It's kind of fun. Like the day where we see him switch into exploration mode is, I want to say, within a month. In his journal entries, which we didn't use, but in his journal entries, he says, "Okay, I'm putting aside my notes. I'm ready to write." And when he actually writes Origin of Species, he then switches into this exploration. So it's a great, I think it's a great example. Like I say, should this invalid, is this the Popperian test of every single machine learning model that says you explore then exploit? No. But I think it's compelling, the troubling thought that we're really here to talk about not just multi-armed bandits and these little toy models. If we really think we're getting at what superintelligence looks like, or even intelligence looks like, it's a little troubling that it doesn't fit our model. Like, here's a good example of, was Darwin a superintelligence? No, but he was doing something, and he's breaking the pattern. Yes. Start. There's some subtleties here, and we can take it offline to get the details right. There's a difference between this local and global exploration, and he gets locally exploratory at this Vestiges of Creation early. And that's basically, he's like reading here in biology, and he's like, "Oh, okay, Barnum," right? So he jumps into, like, for example, he jumps into that, he does pigeons, right? So now he's kind of jumping around like this. He's making these leaps, but he's basically bouncing around the same area, right? So he's got a local exploration going, but he's not leaving that space. Yes.
And if I remember correctly, you had something like 80 to 120 topics. So it's fairly specific. It's not just bouncing around between biology and
Yeah.
physics.
Yeah. So how do we actually quantify distance in this library, right? We do a topic model. So Jamie, we had early access to some of the full text digitizations. IU was involved in an early project to digitize all of these books. So we had the raw text. Jamie could do a topic model that enables us to identify the kind of composition of the book. It's word co-occurrences. It's imperfect. You can look at the topics, and whenever you do topics, they're pretty darn good, right? Like, oh, that's the barnacle, right? That's the pigeon sex. So it's not just like Dewey Decimal System. But what's her? One of the last books that I think it was published posthumously, was actually Expression of Emotion in Man and the Animal, which is early evolutionary psychology. Like, quite amazing stuff. I'm not a Darwin expert. I ended up talking to Janet Brown, who's Darwin's great biographer, classic humanist. We had a very productive conversation. Of course, for her, she's like, "Well, yeah, I know this, right?" And of course, we do want some kind of coherence between what we're finding quantitatively, which is qualitatively. What's nice is that what's our metric? Kovac library divergence, right? We're looking at the KL divergence between text A and text B. Those are a distance, which is something, an innovation we had to discover. But yeah, I think Darwin it's a great place to begin this conversation, because we're just putting it out there. Like, he didn't do that. Now, maybe he's special, and maybe the rest of us normies should be, we're playing the multi-armed bandit game. It might be useful to think about how, really how Lighthaven works, but like, maybe don't tell a newcomer to Lighthaven, like, go hang out, talk to lots of people. Instead, you'd be like, lock yourself in a room and talk to one guy.
There's a difference between like talking to people and and like spreading yourself across many topics, right?
Yeah. And I mean, I think one of the things here, of course, is like, Darwin's reading books. He's doing a lot of other things. So we have his letters. We didn't have the text at the time. Darwin's letters are really interesting. What he's doing there. It seems like his letters are paralleling his reading. Just me looking at them. But question.
Here. Break.
Mm-hmm. Yeah. So we have some on that, and I'll get to the group level question aside, right? So you're right. This is very much individual level, right? And that's one model for how to do science. I mean, I think it's quite. I mean, you look at someone like Jim Crutchfield is thinking really hard, and he's also in an interaction with others, right? I mean, if you guys read Jim's history of computational mechanics, it's kind of amazing to see this photograph. The grades that are there, they're all certainly individual Darwin, and then there's the question of how they interact. You asked me what's the message from the Darwin paper? I think there's three messages. The most important one, I think, is this meta message, right? We wrote this paper in part because there were a lot of theories about how we should acquire knowledge, how that works. And let's test them empirically. And let's go beyond, for example, either theoretical tests, like, oh, I have an agent with a multi-armed bandit. Go beyond those tests. Let's also go beyond, and this is really critical, go beyond the kind of psychological, put an undergrad in the lab for 15 minutes and $5 apartment, right? Because what we really care about, and I say this quite a bit, you want to study people when they're doing things that matter extraordinarily much to them. So a lot of what we worked on Darwin, like we worked on the French Revolution, we worked on a lot of historical moments where it's super high stakes for people. And when things are really high stakes, things get really different, right? You're not going to see how somebody behaves altruistically in a lab and understand how that transfers over to like self-sacrificing. That's intuitive to us, right? What's I think in the same case in knowledge acquisition and knowledge creation, we're trying to find these. So I think that's the first message. Things get different when it really matters. I'll say briefly, and then we'll talk maybe about the Royal Society list. One thing that we did look at Less Wrong. So Less Wrong is a great example of a collaborative with people. So we scraped all of Less Wrong. Didn't ask Oliver about it, but I'm sure it's. But like Less Wrong is a great database now I mean, it really mattered to people, right? This was not like they weren't getting paid $5 to post, right? These are people really engaging over many years in something that's profoundly important to their own lives, to their intellectual lives, their personal life.
Some of us, our careers.
There you go, right? So that's the kind of stuff that you want to look at. If you want to understand intelligence and how it's working, look at where people are really engaged. Yes, question. Yes. So sorry. First one is like, go big, right? More is different and a more investment, right? And when you do that, you discover unexpected things. I think that's the first takeaway. It's a meta takeaway about what we should be doing when we're doing this. Second one is like, well, maybe explore exploit is wrong. And I've been thinking about why that might be the case. Well, I think one of the things that's going on is that, you don't know how to make sense of what you're reading until you read a lot of it, right? It's very different from a utility function. Someone says, what's the utility function, right? Darwin's pushing button. When it's a multi-armed bandit, I know I get a candy or not when I push the button with some frequency. I know what the candy means. I think one of the reasons that that's totally intuitive, reasonable thing to believe doesn't work, right, is that the utility function that Darwin has is not clear, right? And he was either smart enough or lucky enough to know that. And so instead of pushing lots of buttons and seeing what the candy was, he didn't even know what it tasted like until he really, that's right. That's part of it, is that what you're learning in part is the value system as well as acquiring information. I think that's one reason. Yeah.
Your work won't tell us if Darwin went through an explorer phase before the voyage of the Beagle.
That's right. Yeah.
And presumably he did do a certain amount of learning to read and do math and possibly Latin and just the general education he would have gotten.
Yeah, he was not a successful young man. So there's a famous letter from his father. There's a famous letter from his father, which is something along the lines of like, you will amount to nothing. You are a huge disappointment. to me. You were good for nothing but like hunting and rat catching, right? He signed up for the voyage of the Beagle because he was a bit of a lost soul. What he was doing with it.
So you're saying
Yeah.
people might have tried to make him explore, but he was
Yeah,
not
I
good
think
at
they
it.
sent him to Eton or one of these, bullshit private schools, and he learned Latin, which was, I mean, it was many people. Yeah, I mean, he was up in Edinburgh, and he was working with somebody there, sort of, but the guy kind of stole his stuff, and it was a real bad scene. I mean, he did not like there was not like a secret preparation phase that we know. It was mostly a lost man.
Beyond like a sort of normal human amount of getting exposed to.
Yes, and there's one exception to this. So we know that he was an obsessive type. He was an exploiter in the following sense. So I there's a great story of Darwin. He was obsessed by beetles. Right, as a kid, he was like collected beetles. And there's a great story where he's like hunting in his dad's country house, and he's like, oh Christ, look, a rare beetle, got one, and then another one, and he's got two rare beetles in his hand, and then he sees there's a third, like it's a great day for beetle hunting. He's a third beetle, but like what's he gonna do? So he sticks one in his mouth, takes the other one in his hands, and now he's got his three beetles to carry. Right, so in one sense, like this guy is a hyper exploiter. He is a beetle fanatic, right? He's somebody who can, in some ways, not ADD or something, but he had the hyper focus ability as well. So there, if anything, he was like a secret generalist reading everything beforehand. Yes. Be great. Be great. If somebody wants to do this, we have funding and we can do it. Partly we're like body limit, we're human limited, right? This work is tricky, right? I mean, even scraping less wrong is tricky. And it helps that I know you guys, right? So I kind of know like a bit what's going on. But like there are phases in less wrong and they switch on a new system here and that kind of thing. And it's growing and all these things like, oh, there was this overcoming bias fight. So but building that historical knowledge is really, that takes time, right? So we had to learn about Darwin. That takes time. If we did Teddy Roosevelt, it's going to take some time. And if someone wants to take the time, let's do it. But I think it's a wonderful question. You had a question.
I know. And
It does. I mean, I'm always careful. Like I've gotten wrecked so often by things that I think are true. The woman to talk to about this is Alison Gopnik. It's our great child psychologist. She has a wonderful book, and there's online lectures as well. Children are baby scientists, and looking at how children reason, looking at how children solve problems. There are puzzles that you can give to a child that they will solve faster than an adult, for example. The reasons behind that, the reasons children get into these things, I want to be a little careful. Like, I don't know, which means I'm a killjoy for brainstorming. But I think it's a really interesting question. Put it this way, what's the role of culture, right? Do children in, like we've worked on the Tsimane, it's the indigenous culture in the Amazon basin. Do Tsimane children do the same thing? Do they get really into stone, right? In the same way that, I don't know, a kid in Palo Alto gets really into cars, I don't know. But really worth wondering, what's the cultural component? What's the evolved component? What's the, idiosyncratic genetic and parental culture component? Those are really big questions we don't know the answers. There was this question about the interaction, right? So we got Darwin, but we also have the field questions. So talk a little bit about that. Success stories are easier to study because they tend to be preserved better. That's a separate bias that we can talk about. But this big success story we studied was the Royal Society. So the United Kingdom, or it began as England, didn't unify yet. The United Kingdom, the folk story on this. So the guy called Francis Bacon, the Utkowski of the 17th century. And Francis Bacon is not a great scientist, but he's like looking around and he's like, I think this science thing is going to be. And he writes something called the New Organon, which is like the sequences. The analogy is actually pretty good. And he writes fan fiction. This is actually, it's funny. I'm talking about this out loud. There are bizarre parallels here. So Bacon is, he's got something. He's like, there's something here about science, and Aristotle is probably over. So the new organon, like I have a new like set of aphorisms about how we should seek science. He's wrong about a bunch of stuff. Like he thinks magnetism is fake, but he's got a whole sort of story about this. He writes these beautiful fan fiction pieces. We would call them fan fiction. So he takes the Greek myth, but he's like, but add science, right? And so, it is like Harry Potter and the Methods of Madness. It's actually bizarrely close. So he writes, for example, he writes the myth of Oedipus, right? You know, Oedipus who like bangs his mom and stabs out his eyes. But he actually leaves that part out. The thing you forget about Oedipus is, why is he king of Thebes? And he's king of Thebes because he solved the riddle of the Sphinx, right? Like, this guy was great, right? So the whole thing is like, you're waiting for the bad part and it never comes. And it's like, okay. He has a great thing about immortality, right? So he retells one of the myths of, I mean, when people discover science, they get really into not dying. And so he retells one of the myths where this person is granted immortality, but forgets the difference between lifespan and health span. And so the person age forever, right? So it's a cautionary tale. So he writes that. And then he also writes something called New Atlantis. So Atlantis, the mythical island of joy and pleasure, now Santorini, destroyed in a volcanic explosion, still in cultural memory. But he writes New Atlantis, and he's like, I'm going to imagine an island. On the island are these people, and they don't have the word yet, but they're scientists, and there's like different houses, and this is like the biology house, we would call it. So he tells a science fiction story about the way, and we don't have that word yet, but he tells a story. 60 years later, a bunch of intelligent, wealthy people in London are like, let's do it. Let's build New Atlantis. And what they build is the Royal Society, which is the first scientific organization, the first institutional scientific organization. And Royal Society was a great success, right? It's probably why Britain won the Industrial Revolution, or was a key part of it. Starts in the 1660s. Charles II is the king who like stamps his seal of approval. And they have a little clubhouse. They have a journal, the first scientific journal. I should say the first scientific journal that still exists, because there was a French journal, but things did not go well in France. So it's the first scientific journal, and this is great for us because from I forget the exact dates, let's say 1660 until 1870, it's the only journal, right? A couple others start later, but it's got a continued publication history. We stopped in the 1870s because then it splits into, proceedings A and proceedings B, and now it's going to, it gets more complicated to track. We're just like, let's take the simple case where we have uninterrupted publication series. So the Royal Society basically publishes everything you care about in that period. It's insane. Nearly everything is in there, except, interestingly, Darwin. So Darwin he publishes one paper in the proceedings, and he admits it. It's like, this was not a good paper. I should have just stuck to writing. The highlights here, it's like, the wave theory of light's in there. Also, Bayesianism is in there. So the Reverend Bayes, that's where it's published. And it's actually really worth reading that original paper because it's really good. It's one of the few people, no one understood it. It was not till the 1950s that we really understand it. But it's remarkable what they published. So this is our new Darwin, right? This is our collective discovery. And so we can look in there and we can say a couple things. One is we can look at that history and see where these ideas are coming from. And one of the things we're interested there is what are the decision principles that scientists are using to figure out what to work on next, right? So, you're a scientist, you have the proceedings, you're maybe in London, but in fact, great papers from Pennsylvania, Ben Franklin's in there. You have to figure out, what are you going to work on next? What are you going to publish? And the proceedings gives us this window in. So we're looking for their process. We come at a bit theory heavy, which is good, actually, because otherwise it's just anecdotes and they're really fun. In the 1840s, there's a guy called William Whewell. That if you go to Cambridge, Whewell was the president the commander of Trinity College, Cambridge. So there's Whewell Court. But Whewell was a friend of Babbage. He was in the scene. He was not the greatest scientist of all time. And I think he quickly realized, like, wow, okay, so the Royal Society's been around, it's been like 100, 200 years. Science is like really good. And we should probably try to figure out why. So he's the first person who tries to figure out what this thing is that is science, what we're doing, what's the logic. Right? It's a book called The History and Philosophy of the Inductive Sciences. And he comes up with this theory, which he calls consilience. So this word consilience you may have heard, picked up over the years. So consilience is the following idea. You have phenomena A and phenomena B. I'll give you an explicit example in a moment. You have two experimental things you're noticing, and you have two explanations. This one, explanation 1 explains A, explanation 2 explains B, right? You seeing that? And then one day you notice that explanation 2 also explains A. So 1 can do this, 2 can do this, and then you discover, oh, wait a second, 2 can also do this. He calls consilience. And on that basis, you should prefer this theory. This is a thing to work. This is a principle. His example is beautiful. He doesn't realize this at the time, but there were two phenomena. One was, I'll use the modern terminology. One is, you have like a puddle and there's oil in the puddle and there's like a rainbow color, right? So that's one thing they observed and they're like, what? What's up with that? There's another one, which it's just a double slit experiment, right? It's like fringes, right, of shadows. So we got these two phenomena. And they had two explanations. The rainbow thing had one explanation. The double slit had another explanation. And then one day we realized that the theory of alternate fit, aka wave theory, could also do colors. And on that basis, we started to prefer the theory of alternate fits to this theory whose name is. And like, good thing we did, because that's everything. And in fact, he doesn't even realize how big that's going to be. That's going to be the origin of quantum mechanics, origin of light. So this is consilience. One thing that's worth pointing out is this is actually crazy. There is no Bayesian reason to prefer consilience, right? This is not a good principle. It is a good principle if you think, constructed the universe to low Kolmogorov complexity, fine. But it's actually kind of it's a non-Bayesian principle. It's a principle, by the way, that works extraordinarily badly in the social sciences. Marxism explains everything. This is not a good reason to work on Marxism, right? But it is a good reason to work on quantum mechanics. And so in the Royal Society, what we looked at was how people were essentially choosing to work on topics on the basis, on the extent to which these topics were able to unify other topics. And so you find this kind of remarkable. So you can measure that preference over time. You can measure that sort of drive towards unification, that consilience preference. And I'll drop my hand, right? It's like from 1600 to 1750, it's flat. Meaning people are writing papers, they're combining things, they're choosing what to work on, they're choosing things to combine. It appears somewhat random. Right? One of the examples we had in a competition a couple of days ago was the Lisbon earthquake happened. There's this earthquake that destroys Lisbon. It was so they had a special issue on Lisbon earthquake. It's like earthquakes, like what's up? And I mean, you look at the papers and it's insane. It's like, do cows cause earthquakes and deductive logic? Like they don't get, right? They have no systematic way to put things together. So it's flat. Round about 1750, you see this preference emerge. There's actually a saturation point around the 1850s, right? And it goes like this. Right? And what we're studying there is, it's somewhat similar to Darwin, right? Darwin has to figure out what to read next. These scientists have to figure out what to work on. And we can see them being drawn. I mean, Hewitt was right? He wasn't wrong, right? He had his particular case study, but he wasn't wrong. And it looks like this preference sort of starts. The preference works extraordinarily well because, in fact, in that period at least, right, this was the secret. This is what you should do if you want to discover great things. The obvious examples: electricity and magnetism, wave light. All of that is being driven by this concept. So, what's the takeaway from that? Takeaway from Darwin, like exploit then explore, right? Do the opposite. The second one is, it's a combination of things. One is, of course, like we should look for unifying theory. That's one thing. But the other thing is this institutional question of how did we build a system where that became possible or, preferable for people. 1750 is a kind of big moment where this preference starts to emerge, detected in the data. They made some institutional reforms to the Royal Society. So the Royal Society was fan fiction. It was like, let's do it. Not much happened. Like, it's a bit of a failure for the first, let's say, 100 years almost. It's a bit silly, and people laugh at it. There's cartoons that make fun of it in, like, the newspapers. There's this kind of alchemy vibe to it. And it gets so bad eventually that the trustees or whoever, people high up in the history, is a little complicated, but the trustees are basically like, look, we need to, like, bring some real people in here. And they actually kind of formalize it. They make they bring in peer review, for example, into the journal. They stop, like, the wealthy people no longer get to publish their papers in there. No more Latin, don't mind. So a lot of reforms happen that make it look like a modern journal that happened in 1750. And if you want to tell a correlational story, like, that's when things get going. Yes, and then yes. Newton's a weird one. And I'm not sure of Newton's dates and whether we get anything from him. He's a little bit earlier. So before you can have the Royal Society, you need to have people willing to share their results. Hooke is in there. The person who like the secretary, the kind of bureaucratic genius behind it, called Henry Oldenburg. And what their main goal is to take what we used to call the Republic of Letters, which was scientists writing letters to each other, and to basically make that more transparent. So instead of letters being circulated among geniuses, they could just publish in the journal, and then you could buy a copy of the journal and you could see all the letters. And it's one of the reasons why we call them letters. Yes, and then yes. Yeah, they did not have a formal referee. There was a referee too, right? And so exactly what peer review means, it's a little hard to say. And again, that's more, if you're interested, or one should be interested in this, it's a question for the historians and digging into the archives to see exactly what was happening. But certainly one thing that was happening was that you didn't get a free pass to publish anything. And there was a sort of pre-filtering that was conducted by a smaller number of people. Yeah. Yeah. Oh, I didn't know that. Yeah. Yeah. Newton's he's an odd exception case, and that's a lovely phrase. Yeah, I mean, part of this is systematizing things, right? Like, people publishing in the proceedings are a bit more normal, right? Maxwell was a wife, and like, took holidays, things like that. Darwin was unusual too. I mean, he was very wealthy, so that's partly why he wasn't too involved in the Royal Society. He didn't really have to. Could publish his own books, living.
One of the big questions for me is what could have happened to speed up whatever the focal development is. It sounds like you're saying maybe one of the things is if the Royal Society had professionalized earlier, these discoveries have happened faster?
So I think this is a really good question. Here's another way to phrase it, right? We the scientific method with Francis Bacon. Basically, the kind of standard, you do an experiment, comparing, but like the idea that there is a method to science, there are kind of rules. Today we think like pre-registration, like that very notion, Francis Bacon, he's weak. Then the Royal Society starts and institutionalizes this to a certain extent. Why was it that 100-year gap, let's say, before the 1750s when we start to see things really come together? One answer is indeed like a kind of local answer. It's that this was still a bit of a boys' club, gentlemen's club. There were sort of too many amateurs, let's say. There wasn't this sort of professionalization of, okay, is this a good paper or not? Or that's one thing. There's a wider context in which it's occurring. And so economic historians have wondered this question, like, why did, like, Britain have the coal, right? It had the democracy because of the Glorious Revolution. It had rough stability, but again, thanks to the Dutch. It had capitalism. It had all the ingredients that we needed. And yet somehow we had this gap of 100 years. One answer is the idea that you needed some kind of feedback. And the economic historian Joel Moker talks about this in many books. Gifts of Athena is probably the classic book on this. He says, look, you have this theoretical knowledge, right? You have singular learning theory, right? You have theoretical knowledge, but you also have practical knowledge. So back in the day, for example, you had thermodynamics and you had steam engines. Moker calls this lambda knowledge. I don't know why he calls it lambda knowledge and omega knowledge, right? Lambda knowledge is theory, right? Singular learning theory. I guess lambda, right? And then you have omega knowledge, which is practical knowledge. If you can get these in a virtuous feedback, then you win. The scientists come up with an idea, it helps you build a better machine. The machine leads to new phenomena that the scientists then have to explain. And you end up in this kind of feedback that seems to be the thing that triggers it. To get that feedback loop going, obviously you need good lambda knowledge. You need structures in that society that prevent it from being like whatever, a social club, for example. You also need this translation. So a lot of these papers are hard to read. And they're not written in a way that a practitioner who's got a business to run can read them. So Moker has a lot of great stories of the kind of historical accidents that feedback. One of them is, and I guess the analogy is, one of them is Wikipedia. So Wikipedia is great. And it's an encyclopedia that takes scientific stuff and makes a little less esoteric. Right? In this meeting, like I have gone to Wikipedia a lot to figure out what was Riemannian geometry? Oh yeah. So there were actually encyclopedias that got written in the early 1700s, they were like, oh, here's an entry on candles. And the entry on candles like sort of mixed together some of the chemistry of candles, but also told you how to make a candle, sort of thing. So these were kind of important bridge works. There was no institution to make those encyclopedias, but they sold really well, so capitalism made it work. But that seemed to be part of it. So if you want to build one of these, if you want to build like your Light Haven or whatever it is to make it work, you need good structures in Light Haven. You also need this kind of context. This is true at Santa Fe Institute, where I am as well. We have people who make money for a living. Like we knew about deep learning before most people because we had people who worked for Google who were trustees, and they were random forests are too good. There's something odd. Like they were bringing us that information to get ahead. You had a question. Yeah. Yeah, I think there's some evidence for that. I mean, you look at someone like Ben Franklin, right? Franklin was, ended up what we might think of as an aristocrat, but we didn't have them. Franklin, he's an apprentice, so he knew how to make a right? So he could fly a kite in a lightning storm. Darwin was an interesting case because he was an aristocrat, so he didn't really have to work for a living. But aristocrats love breeding horses. So, yeah. Wonderful. So whatever started happening in 1750, right? It's not just physics. I mean, I'm bringing up electromagnetism because we all know it. So it's also like boring stuff, right? Stuff that's boring to us, like agriculture, like cows eat. Okay, what's going on? How do cows eat? What's metabolism, right? I mean, like there's some like if you look, for example, what people are linking together. Like, yes, you see electricity and magnetism. It's great, right? But you also see like, oh wait, demographics, like how many children are dying, and like geology, soil quality, nutrition. They're making so the discoveries that happen after this transition. Concilium.
When we talked earlier,
Mhm.
you talked about how Darwin was like a spider in a web. He was not talking, he was not going out that much.
Yeah.
He was mostly exchanging letters.
Yeah.
Also much like Eliezer Yudkowsky. Whereas the Royal Society was very much a social mixing thing. From which one might conclude that both mechanisms work and you don't have to go isolate yourself and exploit.
Darwin was, I mean, his letter writing is really interesting. It fits in with something Linda was saying earlier. Darwin is writing letters. That's how he gets his information. I mean, after the Voyage of the Beagle, he doesn't really leave. But he is really adept at getting information. And one of the things that's striking about Darwin is that he's willing and able to get information from people who have jobs, like real. So he gets information from farmers, he gets information from pigeon fanciers. A lot of his knowledge of how heredity works is coming from really detailed accounts that he's getting from, gentlemen farm, like not people that his social class would mix with usually. He's a very wealthy man, heir to the Wedgwood fortune, China fortune. So I think in one sense, there is a kind of connection there between what the Royal Society is doing when it sets up this Omega Lambda cycle. Maybe Darwin can make that progress early on because, yes, he's bringing that information in through his letter writing, but he's bringing in that kind of Omega knowledge that he's then using to advance his Lambda. So it's early, like that crisis where he's like, oh, I could have written Vestiges. God didn't. Like my Lambda knowledge was wrong. Now what I need is Omega knowledge. I need to read pitches. Question, and then Clem can finish us off. So you had a question? Or were you just touching your hair? Yeah, did you have a question? All Einstein is working very much in among an amazing group of people, right? Like we call it Riemannian geometry for a reason. We call it the Lorentz signature for a reason. They're theorists, but they're working together. And I mean, it's not crazy that Einstein was a patent clerk. So it's an odd story. It's more like a postdoc, like he had a kind of gift postdoc, that clerk story. But they were in contact with the experimentalists much more closely than, like, say, Ed Witten is today. There was a question over here. They kind of predated. And if you look, I mean, the British had their own revolution, the Glorious Revolution, and it's glorious because no one died. And so one thing you might say is that you need the political rearrangement before you get the epistemic rearrangement. If you want to extract a lesson there, one is coming sort of before the other. Frankly, I mean, the colonies are effectively self-governing in the 1750s anyway. But I think these are deep and wonderful questions. My hot take is politics comes before epistemics.
In which case, maybe the Royal Society reorganizing in 1750 couldn't have happened much earlier.
You needed people to really get sick of the aristocrat, and they had run the torch by that point. So that might be one.
But had they run it like 10 years before, 100 years before?
That's a good question. Historical counterfactual.